Hey Longhorns! So this is my first 8th grade video, so please be nice in any comments and questions. I'm going to go through the plate tectonic doodle notes with y'all, and hopefully it'll help y'all understand plate tectonics and what's going on. So I'm going to start at the top. Plate tectonics are interactions of the Earth's rigid lithospheric plates as they move slowly over the asthenosphere, or the mantle. So up here, it's interactions. Of the rigid lithospheric plates as they move slowly over the asthenosphere, or the mantle. We have some evidence for this. The first piece of evidence, it's going to be fossil records. Which, if you look through the stuff I had posted last week, that all had to do with the evidence. So that was from Wegener. There we also have seafloor spreading. And then volcanoes, earthquakes, and mountains are all evidence that our the plates don't just stay in place. They move around and things happen. So what happens when the plates move? Well, Earth's surface slowly changes. And when we say slowly, in the Atlantic Ocean, there is a beautiful example of seafloor spreading. And what's happening is every year it spreads about this much. 3 centimeters, not 3 inches, 3 centimeters. Okay, so I thought I had a ruler. Maybe not. So if you look at a ruler, 1 inch is approximately 2 centimeters. So it's spreading maybe 1 inch every year. And so what that does is, when the plates are moving around, we can create and destroy ocean basins, can produce earthquakes and volcanoes, and form mountains and plateaus. So now, why do the plates move? Well, if you remember when we were talking about convection and convection currents, when we talked about the weather, this was before, this must have been right before Christmas. That was a while ago. So if you remember, cold has a thicker or bigger density than something that is warm. So if something is warm, it is rising. And if something is cold, it generally falls. Okay, so here we have 2 convection currents. One of them is colored much nicer than the other one. And so on top, we have 2 plates. Okay, now as this hot air is rising and then falling, it's actually pushing these plates away from each other because it's moving in the direction of that current. So if you think about, have you seen those not the commercials, but like the cartoons where maybe Tom or Bugs Bunny, they're in a river and they're walking on a log? It has like that same concept where when something's rolling and you're standing on it, you're going to move with it in the direction that it's rolling. Okay? So, in here, what is happening is new magma is rising up to create more rock, more crust, okay? As the plates are spreading apart. So the Atlantic Ocean floor spreading, or sea floor spreading, so the 3 centimeters that it's spreading, there's new magma and crust that's being formed as it's spreading apart, okay? And so then on this other side, same concept. Cold air, or magma for that matter, falls. And hot rises. But here, the plates are actually going to collide and run into each other. And so what it'll do is it will, let me zoom out actually, you can see better. And so as these plates are coming together, they're going to form a dip. So it's like a valley. Okay. Now, let me use green. So the plates move because of convection currents. Okay. And again, it moves kind of like that log in the river, but also if you've seen a conveyor belt at the grocery store, it moves like a conveyor belt. Moves like a conveyor belt. And so here, I forgot to mention this. Here the plates are moving away. And here the plates are moving together. So now that we know how the plates are moving, we're going to talk about the 3 different boundaries. The first one that we're going to talk about is convergent. Or coming together. Convergent boundaries can form volcanoes, mountains, earthquakes, islands, deep ocean trenches, all that. During convergent boundaries, crust is being destroyed. Transform boundaries are the next one we're going to talk about. And so with transform boundaries, what they do is they slip and slide past each other. So they're just moving kind of back and forth, but it's not like they're moving back and then forth like this. It's like they're continuously going in the same direction. But my hands are not, you know, as big as plates, so I do the back and forth motion. And during transform boundaries, crust is neither created or destroyed. But change does occur. It looks different. Okay. So while it's, here, I'll use pens. This will be better. So while they are slipping past each other, nothing's being created or destroyed, but it does look different. And the last type of boundary are divergent boundaries. So convergent means that they're coming together. Divergent means that they are moving away. And this creates rift zones, mid-ocean ridges, and the seafloor spreading. And at this point, crust is created. Now, I know some of y'all are thinking, well, if we're creating crust, why doesn't the surface of the earth or our land surfaces ever get bigger? It's because while we're creating it in some places, in other places it's being destroyed. So if we look at our tectonic map that you should have seen on, I believe it was Wednesday of last week, you can see here, this is the Atlantic Ocean. And you can see that this is a divergent boundary, okay? So the Northern American continent and the African continent are moving away from each other. That is creating more seafloor, more magma is coming up in between them, seafloor spreading. This is the perfect example of it, okay? And so while that is happening here, in other spots, like here, the African and Eurasia continents, they are pushing together. So they are actually being destroyed because, as you remember here, when it's coming together, it's going down. And when it goes down into that magma, it gets melted and joins back into the magma and then eventually may come back up as new crust. Okay? So what is Pangea? We talked about Pangea quite a bit last week, and hopefully you remember. So 225 million years ago, Earth had a supercontinent made up of all the current continents, and it was called Pangea. Okay. Plate tectonics explains how they broke apart and moved to their current positions. Also, the last thing that I want to mention, earthquakes can happen during any boundary, okay? You get the most severe earthquakes during transform boundaries. So, areas like California are actually on a transform boundary, and that's why they get frequent earthquakes, not hurricanes. They don't live in Texas. They get frequent earthquakes, and that's why some of their earthquakes are actually pretty severe. Transform boundaries have the most severe earthquakes That does not mean that they can't happen somewhere else, like on a convergent or a divergent boundary. It just means that the types of earthquakes that you get at a transform are going to be at a higher scale. So like here in Texas, a Category 1 hurricane is not that serious, right? Well, earthquakes are measured on a same scale-like chart, where a level 1 earthquake is not that severe. Okay, so you're going to get your more severe ones on the transform boundary. I don't remember exactly what the scale is for earthquakes, but if y'all are interested, let me know and I can Google that and make another video. All right, Longhorns, hope this was helpful. Office hours are 10 to noon, Monday through Friday. Pop on in, even just to say hi, and just let me know how y'all are doing. We miss y'all. Bye.